Hello and welcome to 11.4. So these notes are kind of a combination of the last couple sections we've done. So in this section we're going to be talking about complex numbers again. On this first page we have a few quadratic equations that we're going to have to, quadratic functions that we're going to have to find the zeros for. And then we're probably going to get some complex numbers for our answers. So you can see what that looks like. So in this first example, notice that one side is equal to 0 already, so that's good. So I can go ahead and start with the quadratic formula. Now, we could complete the square here, but this one I'm going to do the quadratic formula. So I know that A is 1, B is 6, and C is 15. So I want you guys to practice the quadratic formula, which is why we're doing it that way. I will complete the square on one of these though. So quadratic formula says that x is equal to negative b, so negative 6 plus or minus the square root of b squared, so 6 squared minus 4 times a times c. And that's all divided by 2 times a, so 2 times 1. So now I can start doing some of the math here. So negative 6 plus or minus the square root of 6 squared, which is, whoops, not 32. 6 squared is 36. Minus 4 times 1 is 4, and then times 15 is 60, so minus 60. And then 2 times 1 is 2. By the way, make sure when you do divided by 2a that this divided sign goes under all of this thing, all of the stuff on top, not just the square root. So negative 6 plus or minus the square root of 36 minus 60 is negative 24. Ooh, we have a negative number inside of the square root. We used to not be able to do that, but now we can, now that we know how to do complex numbers. So negative x equals negative 6 plus or minus. So to get rid of that negative, I'm going to multiply the square root times I. So I times the square root of 24, all divided by 2. So now the next step is I need to simplify, if I can, I need to simplify what's inside of the square root. So I know that I can simplify the square root of 24. I can break it down. So that's, let's do 8 times 3. 8 is 4 times 2. And then 4 is 2 times 2. So I got a pair of 2's. One goes away, the other one comes out. And then neither of the other two numbers have a partner. So it would be 2 times the square root of 2 times 3. But 2 times 3 is 6, so 2 root 6. So instead of writing the square root of 24, that's simplified to 2 root 6. So x is equal to negative 6 plus or minus. So 2 came out, there's already an I out there, so I just multiply the 2 together. So it'll be 2i times the square root of 6. It's all divided by 2. So now that I have that square root simplified, the next thing I want to check for is, can this number on the bottom, the denominator, can it go into this number and this number? So I only want to look at the whole numbers. Never simplify this with what's inside of here. I only look to see if this number goes into both of these numbers. If it doesn't go into both, then you don't do anything. But since there's a 2 on the bottom and these are both even, we can simplify all of this. So negative 6 divided by 2 would be negative 3. 2i divided by 2 is just 1i, or just I, and the square root of 6. So I divided both of these by 2, so that 2 is gone now. So our answer would be negative 3 plus or minus I root 6. All right, so next example. So I know this is kind of crazy. I'll do this by completing the square. So first thing we got to do is get rid of c. So x squared plus 8x. So think about why we are able to complete the square. Think about what b has to be, what type of number. So what value of c could I make this in order to have this side be a perfect square? So I take half of b, which is 4, and then I square it, which is 16. So I have to add 16 to both sides. So x squared plus 8x plus 16. Negative 24 plus 16 is negative 8, so equals negative 8. So I know the side will factor to a perfect square, so half of 8 is 4 and the square root of 16 is 4, so it'll be x plus 4 squared equals negative 8. So since I'm solving for x, next thing I want to do is get rid of that squared, so I take the square root of both sides. So x plus 4 equals the square root of negative 8, but I forgot something. Anytime you take the square root, got to put plus or minus. So then if I subtract 4 on both sides, so x will equal negative 4 plus or minus the square root of negative 8. So I can't leave a negative inside the square root, but now we know how to get rid of that negative. If I multiply times I, it becomes positive 8. So then I need to see if I can reduce the square root of 8, which I can. So square root of 8 is equal to the square root of 4 times 2, which is 2 times 2 times 2. So we got a pair of 2's, one goes away, the other one comes out. So it reduces to 2 root 2. So x is equal to negative 4, plus or minus. A 2 came out, but there's already an I there, so I just multiply the 2 times the I. And there's our answer. So we got a couple more examples here. I might only do one of these. So I'm going to do the quadratic formula here. So one side is 0, so I can go right into it. So a is equal to 1, b is equal to negative 10, and c is equal to 7. So x is always equal, if I'm doing the quadratic formula, x is equal to negative b, so negative 10. Don't forget to put your a, b, and c values in parentheses. So plus or minus the square root of b squared minus 4 times a times c, all divided by 2a, so 2 times 1. I can simplify a little bit here. So negative 10 becomes positive 10. Negative 10 squared is 100. And then 4 times 1 is 4. 4 times 7 is 28. Oops. Just make that 28. So x is equal to 10 plus or minus. That's 72 divided by 2. So next thing I look for is, can I reduce what's in the square root? So I happen to know that square root of 72 is the same as 36 times 2. And 36 is 6 times 6. So I got a pair of 6's. So 6 root 2. So 10 plus or minus 6 root 2, all divided by 2. Next thing I want to look for, can this number on the denominator go into both of these numbers? And they're both even, so yes it can. So 10 divided by 2 is going to be 5. So 5 plus or minus. 6 divided by 2 is 3. And there's our answer. So notice this one we did not get I, because there was no negative inside of the square root. So we only get I if there's a negative inside of the square root. All right, and I'll go ahead and do this last example. So we got to get one side equal to 0. I'm going to add 73 to both sides. So x squared plus 14x plus 73 is equal to 0. So now I know a is equal to 1, b is equal to 14, and c is equal to 73. So if I do the quadratic formula, x equals negative b, so negative 14, plus or minus the square root of b squared, so 14 squared, minus 4 times a times c, all divided by 2a. So if I start to do some of the math here, I get negative 14 plus or minus the square root of 14 squared is 196, minus 4 times 73, break out my calculator here, it's 292, all divided by 2. So x is equal to negative 14 plus or minus the square root. 196 minus 292 is negative 96, all divided by 2. So I have a negative inside of a square root, so I got to get rid of that negative by multiplying it times I. So all I do is multiply the square root times I, the negative goes away. Now I need to see if I can break down 96. So square root of 96, let's see, two numbers that multiply to 96 are 12 and 8. 4 times 3 is 12, 4 times 2 is 8. So notice I already have a pair of 4, so I don't have to keep breaking it down. There's no other pairs because it's just a 2 and a 3 left. So I have 4 times the square root of 3 times 2, but 3 times 2 is just 6, so 4 root 6. So I have x equals negative 14 plus or minus 4i times the square root of 6, all divided by 2. So after I break down the square root, next thing I check for is, can this denominator go into both of these two numbers? Yes, it can. So I'm going to divide everything by the denominator by 2. So x is going to equal negative 7 plus or minus 2i times the square root of 6. So I did negative 14 divided by 2 is negative 7. 4i divided by 2 is 2i. And that's our answer. So going on to the next page, this is kind of a continuation of what we did last section, but I'll just go over a couple of these really quick. So hopefully you can do these already. 7 minus 5 is 2. 3i minus negative 8i turns into a 3i plus 8i, which is 11i. So try these on your own. I'll put the answers on here, so you can pause the video right now and try them on your own. I'm going to go through them really quick. So 5i squared, that means I have 5 squared times I squared. So 25 times negative 1, which is negative 25. So on these type of things, I like to multiply all the numbers first. So I'll do 3 times 4 times 5 times 6. And then times I times I times I times I, so I to the 4th. So let's see, what do we get here? 30, 120, 360. Hopefully I did that right. Times I to the 4th. I to the 4th is actually a positive one. So our answer is just 360. And then the last one. So 2 plus 7i and then 2 plus 7i. So 4 and then 14i, 14i, and 49i squared. So 4 plus 28i plus 49 times -1. So your answer should be -45 plus 28i, and that's going to be it for the notes. I went over a little over 15 minutes, so that's why I was trying to hurry there at the end.